Hi, welcome to this lesson on number patterns, sigma notations. In this lesson, we're going to have a look at another property of sigma notation, specifically the placement of brackets. So your bracket placements are very important, not just in sigma notation, but in any notation you write mathematically, because as we know, brackets forms the first letter of the famous acronym BODMAS. So where there are brackets, that is generally the operation that we perform first over every other operation in an expression. So let's have a look at this expression here on the left-hand side. The sum from I equals 1 to n of this entire general term. See where the brackets are placed. Ti plus some c value, which is a constant real number. We are going to claim that that is not the same thing as taking the sum of the general terms first. That's what the brackets are saying on the right-hand side. Take the sum from I equals 1 to n of ti only first, then add the constant number at the end. So where you place the brackets are extremely important, because on the left-hand side, the general term is this entire term here, ti plus c. So every time you're adding I equals 1, 2, 3, all the way up to n, you're adding t1 plus c, plus t2 plus c, plus t3 plus c, all the way up to plus tn plus c. But on the right-hand side, the general term is just ti only. So you're only adding up t1 plus t2 plus t3 all the way up to tn, and then you're adding the constant value at the end. So if I expanded out this left-hand side, this is what it would look like. t1 plus c plus t2 plus c plus t3 plus c plus all the way up to the last term, tn plus c. So can you see you have t1 plus t2 plus t3 all the way up to plus tn, which I can write out like that. t1 plus t2 all the way up to plus tn. Plus, how many copies of c do I have? 1, 2, 3, all the way up to n. So I have n times c. And this t1 plus t2 plus all the way up to tn can be written in shorthand notation as the sum from I equals 1 to n of ti plus n times c. Can you see that's very different from the right-hand side, which just has plus c. On the right-hand side, if you expand that out, let's see what we get. It's going to be t1 plus t2 all the way up to tn, because that's what the summation is saying on the right-hand side. Then you add the constant value just once at the end. So you can see the left-hand side and the right-hand side are not equal, because the bracket placements are defining what operations are happening first, thanks to BODMAS. Let's have a look at an example. Let ti equal 2i squared, let c equal 1, and let n equals 3. Then the sum of the first three terms is as follows. So here's your ti plus c, and this is the entire general term in brackets. So if you add up the first three terms, I equals 1 goes in here, I equals 2 goes in here, and I equals 3 goes in here. And you can see the plus 1 being added inside those individual brackets. So adding that up, we get 3 plus 9 plus 19, which will give us 31. Whereas, if we did the summation first of 2i squared from I equals 1 to 3, and then added 1 at the end, this would be 2 times I equals 1 squared, plus 2 times I equals 2 squared, plus 2 times I equals 3 squared. So you do that summation first, and you'll get a value here, which will come up to 28. Then you add that 1 at the end. So 28 plus 1 is 29. Can you see that 29 is not equal to 31 here? So that is really important of where the brackets are placed, because that tells you algebraically how to do the operations. Okay, so what did we learn from here? Bracket placements are important. Okay. I'll see you in the next one.